In this video, we're going to be working a fluid dynamics flow rate problem, and it has no numbers. But problems with no numbers are what I call what-if problems. What if I double the mass of the Earth and triple the distance from the Sun? What will happen to the force of gravity between the Sun and the Earth? What if? So in a what-if problem, we're comparing an old situation to a new situation. So here's the problem. During a marathon race, a runner's blood flow increases to 5 times her resting rate. Her blood's viscosity has dropped to 85% of its normal value, and the blood pressure difference across the circulatory system has increased by 50%. By what factor has the average radii of her blood vessels increased? Again, a what-if problem. The nice thing is there's no unit conversions. You have this initial situation. It's inferred, not explicitly stated, that to begin with, the before race conditions, everything was normal. Her flow rate was her flow rate. Her viscosity was her viscosity. You don't have to look up anything. It's just what it was. It's a normal value. And then you have a changed situation. After the race, her flow rate went up 5 times. So that's the after situation. And you're going to compare the changed conditions to the initial conditions. By what factor has this average radii of her blood vessels increased? You don't know what the original average radii was, just how much did it increase? So you're going to list the initial conditions. I know it seems silly, but it's helpful to do that. Flow rate was flow rate. Viscosity was viscosity. The change in pressure was the change in pressure. The radius was the radius. No numbers. And then you're going to list the changed conditions. The new flow rate is 5 times the old one. The new viscosity is 0.85 times the old one. The new change in pressure is 1.5 times the old one. What happened to the radii? Okay, you're going to write down the equation you're using, and then I rearranged it for r to the 4th. We could do it to the 4th root of r and just have r equals the 4th root, but I didn't want to carry that symbol all the way through. And then I plugged in the changed conditions. The new radii, r2 to the 4th power, is equal to 5 times the old flow rate, and 8, part of the equation, times 0.85, the old viscosity. And L, the length of our circulatory system, did not increase or change. It's not mentioned in the problem, so it didn't change. And then it's all divided by 1.5 times the difference in pressure and pi. And of course, pi didn't change either. Okay? After you do that, you're going to go ahead and gather together the numbers that actually changed. So the numbers that changed included this 5 and this 0.85 and this 1.5, and so I gathered them all together right in here. Notice I left the 8 in the problem because that's part of the original equation. It's not something that changed as a result. So I gathered together all those numbers in one spot, and I did my arithmetic. So now I have the second radius to the 4th power is equal to 2.83 times the flow rate times 8 times viscosity times L divided by the change in pressure and pi, where Q, viscosity, and change in pressure is the original situation. So we have this number, but from the original equation, we know that the original radius, not R2, but R to the 4th, is equal to Q8 eta L divided by delta P pi. So this number right here, or this set of letters, is really just the original radius to the 4th power for the original conditions. So we can just go ahead and substitute in. The new radius to the 4th power is equal to 2.83 times the original radius to the 4th power. Well, now we can take the 4th root on both sides, and we get the new radius is 1.29 times the old radius. That looks like it should be the final answer, but before you put it in, go back and check exactly what the problem is asking for and what the units are. So by what factor has it increased? And it's a percentage. So if R2 equals 1.29R, the percent increase is 29%. And be careful when you're entering it into WebAssign. The answer needs significant figures and it needs to be rounded. Keep all the numbers in the calculator until the very end and then round. And that's the end of the problem. Thank you very much for your time.